Okay, so as always, we start by reading the entire question. In the given quadratic function, a and c are constants. The graph of y equals f of x in the xy plane is a parabola that opens upward, has a vertex at the point h comma k, where h and k are constants if k is less than 0, and f of -9 equals f of 3. Which of the following must be true? And then we're given a couple of Roman numerals. So we've read the whole question. We ask ourselves what concept is being tested. Clearly this is quadratics. We have a standard form quadratic here. I'm going to actually jot that down. Standard form, ax squared plus bx plus c is standard form. They might also be testing us on vertex form. In fact, in College Board's official explanation for this question, I do believe they use vertex form. I'm not going to end up using vertex form, but whenever we see vertex and we see h comma k, which are the coordinates of the vertex, they might be testing vertex form. I'll write vertex form here just in case, but again, most likely going to avoid using vertex form on this question. So quadratics, standard form, vertex form, the various forms of quadratics, they are also testing us on parabolas and how parabolas are oriented, whether they open up or down. This part here, important to recognize that they might be testing us on axis of symmetry, which we are going to use. That's going to be a key point of information. And so that's what we are being tested on. What are we given? We are given the standard form equation for this parabola, for this quadratic. We are told that the parabola opens upward. We are told that the vertex is at hk. We are told that the y coordinate of the vertex is less than 0. And again, we are told that there are these two points, -9 and then some y value, and 3 and some y value, where these two y values are equal to each other. So these will be 2 points on the same horizontal line. Again, we'll deal with that in a moment. And then what do we need? We need which of the following must be true. So we have read the whole question. We have figured out what concepts are being tested here. We've gone through what we're given, and we've circled what we need. We are ready to start attacking this question. Now, there are several ways to do this question, some easier than others. The official explanation from College Board that I just referred to, I think, is probably one of the more complicated ways to do this question. But regardless of which way you do this question, there are a couple things to digest from the question. So let's jot some of these down. So first of all, we are given that this parabola opens upward. Remember that when a parabola opens upward, it tells us that the a value is greater than 0. Now, before you jump at Roman numeral 2 and start trying to figure out whether Roman numeral 2 is true or not based on what we just wrote, don't do that, because all we know is that a is greater than 0. We don't know yet whether a is greater than 1. A could be a fraction like 0.5. It could be 1.5 as is this point. We just know that a is greater than 0. Keep in mind, if a parabola opens downward, that tells us that a is negative. A is less than 0. So a is greater than 0. That's one thing that we do know. Another thing that we know is that the vertex is at h comma k, where that k value is less than 0. So this parabola is going to have its vertex somewhere in these bottom two quadrants. We don't know if it's going to be quadrant 3 or 4 yet, but we do know the vertex of this parabola will be down below the x-axis. So we've taken care of a few of those things. Now, this piece of information here, this is absolutely key. And I think this is the piece of information that a lot of students don't know necessarily what to do with. Here's what we do with this piece of information. We know that, I'm going to actually draw an XY coordinate plane here. Let's do 3, 6, 9, -3, -6, -9. So each of those tick marks will be 3. We know that between this x value and this x value, so that's x value of 3, x value of -9, we know that there are going to be 2 points on this parabola that lie on those lines, and that the y values at those points are equal to each other. That's what this equation tells us, that there are 2 y values, one at an x value of -9 and another at an x value of 3, that are equal to each other. Two y values at these two x values that are equal to each other. And we also know that a parabola is, now by the way, I'm placing those y values at a random spot. Technically, they could be down here, they could be on the x-axis for all we know. I'm just placing them in a random spot for now so that we can see that the vertex of this parabola must go through the midpoint of these 2 points. That's by definition what an axis of symmetry is. These 2 points that I drew have to be equidistant from the axis of symmetry, from the vertical line that goes through the parabola's vertex. So it sort of looks from visual inspection like that vertex is going to be at an x value of -3, but the way that we would do this more rigorously is we would just find the average of -9 and 3. That will give us the midpoint between this point over here and this point here. So I'm going to do that right now. -9 plus 3 over 2, that's -6 over 2, that is -3, and confirmed. We have a vertex at an x value of -3. So we have now determined our h value. Our h has to equal -3. Again, still don't know what our k value is, but we do know that our k value is somewhere down in the negative territory. So again, this vertex is now at -3, comma k, where k is some negative number. This parabola, I'm going to draw this in a different color, and then I'm going to get rid of all this stuff. So this parabola could look like that. Oops, missed that one a little bit. It could look like this. It could look very steep. It could go straight up like this, not straight up, but quite steeply up. We don't know exactly how the parabola looks as of this point. It doesn't really matter as of this point, but what we have determined is we've determined that the x-coordinate of the vertex lies at -3, and we already know that the k value is negative. So one more time, we have learned that our vertex lies somewhere in this third quadrant. Now, in terms of where we go from here, so again, as of this point, we have learned that h equals -3, and that the parabola opens upward and all that other stuff. Where we go from this point, probably the easiest way to go is to figure out what a is. And if you know a little shortcut, so I'm going to write down Roman numeral 2, we're going to deal with that a value. If you know this little shortcut, very, very easy to determine what the a value is. And that little shortcut is by knowing that your x-coordinate at your vertex is -b over 2a. So in standard form, you have ax squared plus bx plus c. If you take this b value and you put it over 2 times your a value, you will get the x-coordinate at the vertex, which is that h value. We know that that h value is -3. We just found that. We know our b value. Our b value is actually given. It's 4. So we are going to write -4, just plugging in that b value up top over 2a equals -3. Clean this up a little bit. I'm going to just multiply through by -1, so I get rid of those negatives. When I multiply both sides by 2a, I get 4 equals 6a. I'm going to divide by 6. I'm going to divide by 6, and I get a equals 2/3. And ta-da, we can now get rid of Roman numeral 2 because we have just proven that a has to equal 2/3. Therefore, a cannot be greater than 1, which means that Roman numeral 2, any answer that has Roman numeral 2 in it is out. So that's nice. We're at least at a sort of 50-50 guess here. Even if we couldn't figure out anything about Roman numeral 1, very least we'd be guessing between a and d. So there we go. There's our a value. Now, how do we deal with c? There's a couple of ways to deal with c, but probably the easiest way, so I'm going to write down Roman numeral 1 over here. I think the easiest way is to take the coordinates of the vertex, which we know is -3 and k. Don't know exactly what k is, but we do know it's less than 0. And let's plug those into our standard form quadratic up here. Let's write down k. I'm substituting k in for my y value. Remember, f of x is the same as y. So I'm going to write k equals my a value, which I already know from having dealt with Roman numeral 2. The a value is 2/3. I'm going to plug in that x value for my x's. So that's -3 squared plus 4 times -3 plus c. What is this? 2/3 times 9. You know what? I don't want to make a careless mistake there. So I'm just going to do that in Desmos. Oops. 2/3 times, you know what, just to be real safe, I'm not even going to do that in my head. I'm just going to do all this in Desmos. So that is going to be 6, it looks like. Yes, it is 6. 6 plus negative 12 plus c. That now comes down to k equals, what is that? Negative 6 plus c. I'm just going to do c minus 6. I'm just going to move things around there a little bit. And here comes the sort of final piece. The final piece is that we know that k is less than 0, which means we know that just substituting c minus 6 in for k, since k equals c minus 6, we can just substitute c minus 6 for k. So we know c minus 6 is less than 0, plus 6 plus 6, c is less than 6. So what does that tell us? It tells us that we don't know that Roman numeral 1 has to be true. C just has to be less than 6. It doesn't necessarily have to be less than 0. C could be 5. It could be 0. It could be negative 1. We don't know that C has to be less than 0. We only know that C has to be less than 6, which means we know that Roman numeral 1 does not have to be true, and we are done. So again, easiest way to start, obviously you got to extract all this information. And then once you have all that information, probably easiest to attack Roman numeral 2. There are other ways to find the value of a other than this negative b over 2a, but I highly recommend that anybody taking the SAT knows this little, let's just call it a shortcut, that the x-coordinate of the vertex can be found by using negative b over 2a. In this case, we were able to find a because we knew the x-coordinate at the vertex, and we knew our b value, leaving us with only a here to solve for. So start with a, and then once you have a, we can just plug in the coordinates of the vertex into our standard form equation, find out that c just has to be less than 6, not necessarily just less than 0, and we're done. Now, the way that you can use Desmos fairly effectively on this question is as follows. Before I show you the Desmos method, though, you should know that you really do have to have this h value before you start using Desmos, or I should say at least it definitely helps to have that h value, that x-coordinate of the vertex. When you turn to Desmos, if you type in your given standard form equation here, ax squared plus 4x plus c, I'm going to add all sliders right now. I'm going to pretend that I don't know my a value, but I do know that my vertex has to be at negative 3. So what I'll do is I'll start moving that slider until I can see that, okay, I've got to move the slider. So it started at 1. I right now can see that my vertex is at negative 2. I need to move my slider left to get closer to putting the vertex on a negative 3. And it looks like it comes really close right there. Right there, it's at negative 2.85. That's when a is 0.7. If I move to 0.6, I actually go a little to the left of negative 3. So maybe I'll just make a 0.65. And boom, I get a vertex that is darn close to negative 3. So I'm going to keep a at 0.65. Well, there you go. That tells me that Roman numeral 2 is not right. I can see that a has to be some fraction near 0.6, 0.7, which means that a is greater than 1 has to go. That cannot be true. Otherwise, I won't get my vertex at negative 3. Now, in terms of c, everybody should know that c is the it's the y-intercept. C in standard form, this guy over here is the y-intercept. When I am moving my C slider, I should be able to see that my parabola is simply moving up and down, right? My vertex remains at that negative 3.07. All that's happening is my y-intercept is just moving up and down along the y-axis. So here's the thing. I can remember that this vertex has to be at negative 3, and then my y value has to be negative. So I am moving the parabola up and down using the C slider, and I am keeping my vertex in negative y territory, right below the x-axis. And over here on the y-axis, I can see that C, for instance here, is negative 1.5, right? So again, that's C, that is my y-intercept. I can see that C is at negative 1.5 there. So indeed, C is less than 0 at that point, but I can move my parabola up, keeping my vertex at negative 3.07, somewhere right around 3, and a y value that is negative. Remember, that was a condition from the question, k is less than 0. So I can keep my vertex where it needs to be in that third quadrant, but now my c value, my y-intercept, is positive. So again, I'm just moving my parabola up and down, keeping the vertex in that third quadrant, and you can see that y-intercept is moving from negative territory up into positive territory. Now I can't put my vertex here because then my y value would no longer be negative. My k value would no longer be negative. I can't put my parabola up there, but I can move my parabola up to here. I can see that now c is positive. I can move my parabola down to here. I can see that now c is negative, and that tells me that c doesn't have to be negative. There are positive c values that we can produce here. So again, get your vertex positioned at negative 3, and then just move your slider up and down and see that your y-intercept, your c value, is moving from below to above the 0 point. It's positive, it's negative, which means we can eliminate Roman numeral 1. Those are generally the easiest ways to do this question. It's not the easiest question in the world, but if you know a bunch about quadratics and their associated parabolas, axis of symmetry, shape of a parabola, orientation, opening upward, opening downward, it's not the most difficult question in the world.